Hello everyone, so we want to have physics this afternoon, and remember we've been looking at vectors, and under vectors one of the things that we're looking at the moment is multiplication, right? Multiplication of vectors. Now under multiplication of vectors we did mention that there are two parts. Rather, there are two ways of multiplying vectors. That is number one, we have what is called the scalar, or rather what is called the dot product. Okay. So as the name states here, it means that the answer that you're going to get when you multiply two vectors, let's say A multiplied by B, the answer that you're going to get is going to be a scalar. Okay. It will not have direction, but it will only have magnitude. So it's defined like that. Cos theta, where theta is the angle between the two vectors, right? And then number two, so we already talked about the first one, which is a scalar product. Now we want to look at what is called the vector product, vector or cross product. Okay, cross product. So that's what we want to look at this afternoon, and this topic is very interesting, and I want you guys to pay particular attention and enjoy the lesson. Okay, so what is vector product? Now, from the name, let's just try to derive probably a definition from the name itself. All right, it means that when you multiply two vectors, let's say vector A and B, the answer that you're going to get, the final answer that you're going to get, is going to be another vector which we can call vector C. Okay, that's why it is called what? The vector product, because the answer that you get after doing the multiplication of those two vectors that you have is going to be what? Is going to be another vector. Okay, that's why it is called what? The vector product. In the case of dot product, or rather scalar product, the answer that you get after multiplying the two vectors is actually not a vector, and hence it is called a scalar product. Okay, so we say if we multiply two vectors A and B, right? If we multiply two vectors A and B, the answer obtained is another vector C. Okay, that is A multiplied by B is going to give us another vector C. Okay, that's what it means. All right, that's why it is called what? The vector product, because the answer you get after you multiply these two vectors is another vector C, and hence you are able to find both the magnitude of C and also the direction of what? Of C after doing your calculation. Okay, so now let's proceed. Now let's try to get a deeper more understanding. Let's have a diagram like this. Okay, so let's say we have vector A, two vectors like that. Let's say this is vector A and this is vector B. All right, and then these are at an angle theta to each other. Okay, now the vector product of these two vectors A and B is another vector, like I've mentioned, which is C, perpendicular to both A and B. Okay, so that vector, which we are calling the vector product, has to be perpendicular to both A and B. So I'm going to draw something like this using red. Okay, such that it will be perpendicular to both vector A and vector B. Okay, so this side, let me draw it in full, and then this side I'll put it in dotted. Okay. So now, what we're saying is that we have A and B, which are being multiplied. So this is vector C, which is what? A multiplied by B. Okay. Now, There's something that I want you to understand, what is called the commutative law. Now, of multiplication. Now, commutative law of multiplication, if it were in algebra or maybe in on real numbers, we say that A multiplied by B is equal to what? B multiplied by A. That's what it means, okay? Or if it's on addition, commutative law of addition, we say that A plus B is equal to what? B plus A. Basically, that is what? The commutative law. Okay, this is the commutative law. Now, this commutative law applies, okay, it applies on a dot product. Okay, it applies on what? On dot product. In terms of multiplication of vectors, we say that it does apply on dot product. That is, if we have vector A being multiplied by vector B, all right, this is going to be the same as B multiplied by A. Okay, so these are the same. It's the same thing. So whatever the order, whether you start with A or you start with B, it doesn't matter. But does not apply. It does not apply on what? On vector product. Okay? It does not apply on what? Vector product. That is A multiplied by B is not equal to B multiplied by A. Okay? But what we can say is, but B multiplied by A is going to be equal to the reverse of A multiplied by B. Okay? So in other words, it's going to be equal to negative A multiplied by B. Okay? That's the only way it can be the same. If we apply the negative, meaning that it's reversing. So look at the diagram again. Let's look at the diagram again. We can see that the direction of this vector A multiplied by B, which is C, is going up like that. But if we reverse, okay, so in this case, we're saying that we are multiplying A by what? By B, okay? A by B like that, right? A by B, so it's giving us what? It's giving us, it's going up, okay? If I use the right hand thumb rule, all right, I'm going to do that in the line of vector A, and then I point my fingers, okay? I call my fingers towards vector B like that, and then my thumb is going to point in the direction of what? Of the vector, okay? Of the product. So like that. So my thumb is pointing towards is pointing upwards. But if I reverse, right? If I reverse, I align my fingers along B, and then I call them towards A like that. Then my thumb is going to point downwards like that. Okay, so I align my fingers in line with vector B, and then I call them towards A. Then my thumb is going to point in the direction of the product that we want. So in this case, this is the product. Okay, so the direction of the product that we're getting is going downwards. So this is going to be B multiplied by A, which is the same as negative what? A multiplied by B. Okay, and these two vectors, A multiplied by B and negative A multiplied by B, which is B multiplied by A, they are equal in magnitude but opposite in what? Direction. Okay, these two vectors are equal in magnitude but opposite in direction. Okay, so I want us to write this. We say that B multiplied by A and A multiplied by B are equal in magnitude. Okay, this is separated there in magnitude, but opposite directions. But opposite what? Directions. They have opposite directions, but they are equal in what? Magnitude. Okay, they have equal magnitude, but opposite what? Directions. Okay, so that's how that's how the commutative law of multiplication of vectors applies in this sense, in this case, right? So I hope you're able to see clearly enough. Okay. Now, let's look at something interesting. All right. Let's look at something interesting, and then after that, I'm going to end the video, and then we'll start another one. So let's try to define it a bit more mathematically. Okay, let's try to define it a bit more mathematically. So it's a definition. So what is the definition of vector product? All right. So it says that given that A and B, all right, are any two vectors at an angle of theta to each other. Okay, so there's that part where there's so much light. I'm trying to see how I can possibly get rid of that. Let me see what I can do. So is it obstructing that much? You're not able to see when I write there. Okay, let me be done with this video, and then I'll work on that in the next video. Because I can't pause it. Okay, so we're saying that given that A and B are any two vectors at an angle of theta to each other, then the vector product C, okay, C, which is equal to A multiplied by B, is a vector perpendicular to both A and B. Okay, mathematically, how do we state this? We say that the magnitude of A by B, all right, is equal to magnitude of A, magnitude of B, sine theta. Okay, sine theta. Now, I want us to look at a situation where we have parallel, okay, let's say parallel unit vectors. Okay, parallel unit vectors. Let's look at that. Now, what we're going to have, all right, what we're going to have in the case of parallel unit vectors is that, let's look at this. If they are parallel, then it means that the angle between them is what? 0 degrees, all right, is 0 degrees. So if we get that 0 degrees and we insert it in this what? In this formula here, okay? If we insert it there, it means that sine 0 is going to be equal to what? Sine 0 is going to be equal to 0, right? Sine 0 is going to be equal to 0. Okay. So in other words, if we have I multiplied by I, it's equal to J multiplied by J, which is also equal to K multiplied by K, all right, which is equal to what? 0. In other words, whenever we're multiplying the same unit vectors I and I, J and J, K and K, the answer that we're getting is what? Is a 0. Okay, it's a 0. So we need to to get that in our minds, and then it's going to make our work easier. Then let's look at what is called the right-hand Cartesian coordinate. Okay, the right-hand Cartesian coordinate system. Okay, so this is going to help us to determine the answer when we multiply two different unit vectors. If we multiply, let's say I and j, k and j, and so on, right? It's going to help us with that. Now, if we have, let's say for example, we have that is our Cartesian coordinate. All right. So this side we have y, this side we have z. Okay. And then let's say we have the x coordinate this side. Remember, it's 3 dimensions, right? It's 3 dimensions. Okay. So if that is the case, and then remember they are at 90 degrees to each other. Okay. They are at 90 degrees to each other. Remember, if we are saying that it's a multiplied by b, then sine theta, it means that if where the theta there we put a 90, it's going to give us a what? It's going to give us a 1, right? It's going to give us a 1. Okay? And remember, these are unit vectors, so here it's a 1 multiplied by 1. Okay? The magnitude of the first vector, which in this case may be I, is a 1, and then the next vector, which may be j, is going to be 1 as well. The unit it's a unit vector as well, and then sine 90, which is also a 1, and that is going to give us what? 1. So, but in the case when they are parallel, okay, when they are parallel, the answer is going to give us what? 0. When they are perpendicular to each other, the answer is going to be what? It's going to be a 1. Okay, so now let's proceed and look at how we use the right-hand Cartesian coordinate system. Okay, so this side we have j, this side we have I, this side we have k. Okay, so let's look at a situation where if we have, let's say, I multiplied by j, all right, what are we going to have? And then if we multiply, let's say I multiplied by k, what are we going to have? And if we multiply, let's say j by k, what are we going to have? Okay, then we can reverse these, right? We can reverse them. We say j by I, then k by I, then we have k by what? By j. What are we going to have when we do those multiplications? Now, remember, when you look at this Cartesian coordinate system, it continues. This is the positive side. This is positive. This is positive. This is positive, right? That's how it is. And then if we extend those lines, if we extend like I'm going to extend in red, this side you have negative. Here, if I extend down there, we are going to have negative. This side as well, if I extend, that is going to be negative. Okay, like that. Now, what is I multiplied by j? I by j, I by j. So I'm going to use the right-hand rule, okay? The right-hand rule to do what? To get the product of I and j, okay? So I just use my right hand, okay, and call my fingers from I to j, okay? If I call my fingers from I to j, then the thumb is going to point in the direction of the product, okay? So like this, here I'm starting from I, and then I'm going to j, like that, okay? I start from I to j. My thumb is going to point in the direction of the product, which in this case is going to be what? It's going to be k, okay? So it's going to be k. So I want you to get that clearly. I call my fingers from the first vector to the second vector, and then the sum points in the direction of the what? Of the product. Okay. Then the next one is what? I by k. I by k. So again, I call my fingers from the first vector to the second vector like that. All right. So from the first vector to the second vector, I know this may be tedious a bit for you to master it, but it's very simple. All right. So I call my fingers from the first vector to the second vector like that, and then my thumb is going to point in the direction of what? Of the product. Okay. So from I to k, it's going in the direction of negative j. So this is going to be negative j. Okay. Let's look at j and k. J and k, j multiplied by k. Okay. So again, I call my fingers from the first vector, which is j, to the second vector, which is k, like that. Then my thumb is pointing in the direction of what? Of the product, which in this case is positive I. Okay, which is positive I. Now, when you get the products of the first three, okay, you can see that the other three they are simply the reverse of what we have in the first three, right? So like in this case, this was I by j, here is j by I. So it means that it's just going to be what? To be the reverse of what we have there. So it's going to be negative k. Okay, we get negative k because we are reversing. Then this is k by I. So here we have negative j. So here we're going to have positive I. Then here we have what? We have k by j. All right. Here we have j by k, which gave us I. So in this case, it's going to give us what? It's going to give us negative I. Negative. So this is supposed to be j, and then this is supposed to be negative I. Okay. So that is the right hand Cartesian coordinate system, and then you're using the right hand thumb rule for you to get the product. Okay. I'm sure when you're in grade 12, you looked at what is called the left and right Fleming's rule. Okay. In electricity, when you're looking at electricity. Okay. It's a similar kind of concept. So you just call your fingers from the first vector to the second vector, and then the thumb points in the direction of the product. Okay. So that is, so we need to know them. Okay. We need to know these values, or rather those products. We need to know them very well. Okay. We need to know them very well. All right. So that was basically an introduction to vector product. So now, in the next video, I'm going to explain on the two methods that we can use. All right. So number one, we can use the algebra method. Okay, where we simply expand, and then the other one we're going to use the matrix. Okay, the matrix, or other determinant method. So each of these methods can help us to understand, or rather to get the vector product of any two vectors that we may be given. Okay, so both of them are very simple and very easy to use. All right, so we just need to make sure that we know these products. Okay, so I'm going to end the video right there. See you in the next video.